Hi, my name is Yongxi. Today I'm going to talk about adaptive object detection using adjacency and zoom prediction. This is a joint work with my advisor Tara Jaredi and our collaborators Van and Nesblick. This work is about object detection. State-of-the-art object detection systems such as FastSAR and then use extract region features from a fixed grid of anchors. Here we are just showing one anchor that is coincidental to the object. So for each of the reference anchors, we have a fixed number of references, and for each reference, through regression, we produce some bounding boxes. Of course, some of the references are closer to objects. So those references are likely to produce a high confidence score box, and the box is likely to enclose the object better. In this case, we are showing one reference that is actually closer to the object. Those high-scoring predictions are regarded as region proposals, and then a separating network is used to classify those region proposals and give us a class label. Of course, the problem of this approach is that since you are using an adaptive grid, you need many anchors to cover objects of all scales and aspect ratios. So I have emphasized the bad things about non-adaptivity. So now let me explain to you why we think that is the case by looking at two examples. Here we have shown two pictures. To the left is a cat which is so fat that it basically occupies the entire image. And on the right is basically a buffalo that's much more diligent, so it's small. Now the problem is, since we are using an adaptive grid, we actually need to use some small anchors to try to find small objects. But for large objects, it's actually a waste of computations. On the other hand, for those image with small objects, a lot of computation is spent on some uninteresting regions such as the grasses. So what we propose here is we try to use an adaptive and hierarchical way to generate anchors. What I meant by that is we start with the entire image. We extract features from this entire image that helps us to predict a zoom indicator. The zoom indicator is large when there is small objects inside. And if that is the case, we basically break the image into 5 subregions. And for each of the subregions, we repeat this process recursively. At some point, the current region is actually quite close to the object. In this case, adjacency prediction kicks in. And the zoom indicator and adjacency predictions are all predicted by an end-to-end trained neural network. We call it adjacency and zoom network, or AZNet. The advantage of our AZNet approach is that for images with only large objects, the search actually stops early. Here we are showing the examples of the actual boxes generated from our algorithm, such as the anchors and the proposals. We basically just overlap all of those boxes, so brighter spots means more overlapping. Here you can see that for this cat picture, the search actually stops after just one layer of exploration. And for images with small objects, in fact, what happens is that our algorithm prunes away a large area of irrelevant regions. So what you can see is this gradual zoom-in perspective, and also the proposals. So our algorithm works beyond just a few examples. Here we show our results on VOC207, a comparison with FastSAR RCN. What we are able to achieve is we generate 2 orders of magnitude fewer anchors, and we have a recall of small objects up by 50% and using fewer number of region proposals. Actually, that suggests our approach is the direction towards better scalability when we want to talk about high resolution images and we want to detect small details. For more details of this approach, please stop by my poster. It's actually number 10. Thank you.